Hello, I'm Sean, and this is my presentation on Mosher 2016, the effects of riparian restoration following saltcedar or Tamarix SSP, biocontrol on habitat herpetofauna along the desert stream. Mosher et al. 2016 found that areas that had undergone restoration after being subject to biocontrol had successfully increased biodiversity and species richness along the Virgin River, primarily in southern Utah. So a quick background on Tamarix, or more commonly known as saltcedar. It was introduced as a riparian ecosystem erosion control for high rainfall times. Its origin story, according to Robinson 1965, is a little bit up for debate. It was either brought over from Western Europe via the Himalayas for trade in the early 1900s, or the Spanish brought it up from Mexico. Primarily, Father Escalante was attributed with the credit of bringing it to Utah. So as we'll get into, Mosher et al. 2016 really gets into various restoration efforts. And while we're going to focus on the Tamarix beetle, I thought it would be good to go over some of these other controls because, as you'll see in the future, there are multiple factors in these study sites, these sample sites. So the first one is control. That's reducing invaders' presence. As we'll get into, the beetle falls into that, in the word biocontrol is part of that control element. There's also containment, which is, obviously containing invasive species to a certain area and not allowing them to spread. And then there's eradicate or eradication, which is to remove invasive species entirely from an ecosystem. Obviously, eliminating any ability for them to reproduce because they are no longer present in that ecosystem. So zeroing into the eradication component, I came across Zavalata ES et al. 2001 is one of the research articles that Mosher borrowed some of his research from. And he talks about, in aspects of it, Tamarix and how it affects the riparian ecosystem as a whole. One thing that Tamarix can do is it increases soil salinity, increases that salt salinity in the soil, and can make it more difficult for native species to encroach in if they're more salt sensitive. Another thing that it can do is it lowers the water table. Tamarix requires a high level of water and it draws up that water and over time can lower that water table, making it more difficult for those native plants to be able to access those things as they're trying to take hold again in those areas that have been recovered. Research suggests displacement of native riparian songbirds in some of Zavalata's research. Some are unable to nest because the native species of trees have been displaced due to the monotypic nature of Tamarix. Others are able to nest in the Tamarix. However, they have noticed that the breeding success of those species that do choose to nest in the Tamarix, the success of that significantly drops. And then furthermore, Zavalata brings up that really only solid planning will lead to sustainable restoration, and that doing short levels of restoration and then leaving it unattended can actually have a negative effect on the overall restoration and actually end up taking steps backwards. So the first part of summarization that I'll bring up is Mosher felt there needed to be further research. He felt there was a lack of study on the effects biocontrols had on specifically reptiles and herpetofauna, despite them being such a major part of the ecosystem. An additional effect that Tamarix can have on the ecosystem that they inhabit is they are typically monotypic. Mono meaning one, they push out other species, thereby reducing diversity and richness of native species in the area. And then so this leads into the introduction of the beetle, and the beetle, or Diarrhobida carnulata, or the northern tamarisk beetle. What's unique about this beetle is both in its larva and its adult stages, it exclusively only eats tamarix or tamarisk leaves, which eventually leads to the defoliation of the plant and eventual canopy reduction, thereby that kind of control aspect. It's limiting what can survive in that area. So some of the techniques that were used in the restoration of these sites before this research took place was eradication of 50% of tamarix and other invasive species, other invasive trees, such as the Russian olive, from the area, and herbicide was sprayed on those remnants, on those stumps. Next, they transplanted native species, such as the willow and the mesquite. And then they rerouted water, both from irrigation and stormwater, and I believe from the river as well, via trenches to water these transplants. And then off to the right of the slide, you'll see a picture of the northern tamarisk beetle, and as well as after it's kind of done its damage, what the tamarix looks like. This is an after shot of the picture shown on the previous slide. So some summarization of methods was the distance between the two GPS sites. There were 21 sites monitored from July 2013 to 2014. Those 21 sites were split into 4 stand types based upon dominant plant species in the area. They used traps, including various pitfall traps within those stand types. In addition, they used visual observations, walk-through monitoring teams in order to get visual confirmation of the different reptiles and native plant species and the herpetofauna. They used a neighboring unrestored site to sub for a lack of pre-restored monitorization in the St. George area. And then the lizards that were either trapped or marked visually were marked with a unique toe clip in order to be identified in the future, to not be double counted. Amphibians and snakes were not marked due to their low density and population in the area, as noted in the research. And then they notated over 11 species and their richness as it coincided with native plant densities and diversity within the sites that they studied. So Mosher et al. 2016's conclusions were that lizard abundance overall was 3 times greater at restored sites than unrestored sites, and herpetofauna species richness correlated with native plant species richness directly, primarily the willow and the cottonwood. Furthermore, he notes that reptile populations in the area are likely to decrease with the increasing defoliation due to the Tamarix beetle biocontrol in the area, and that sites will need to be actively managed in order to be effective and sustainable in the long run. So the real limitations to the research that were mentioned was they did not measure standing water on the site, and they did notice a direct link with amphibian and toad counts, and the samples that they took was linked to that water availability, and that it could have very well skewed the numbers that they presented in their research. Furthermore, there was no restoration monitorization or pre-restoration monitorization in place prior to the study taking place, and so they did use, as mentioned before, that space for time component and used a site adjacent to the St. George site. And along with that, though, they only had that control in and around the St. George area. They did not have any other controls in any other areas down towards the Gold Butte area to compare and contrast. So really just that one location that really was somewhat subpar because all of the areas had been subject to biocontrol, and they only had that one control that wasn't a true control. So some of the critiques I have with Mosher et al. 2016 was starting with the coordinates. They required a level of conversion because there was a very non-typical, at least in my experience, coordinates that were laid out, and I actually had to spend several hours on the internet finding the various ways it took to convert those coordinates over to the ones I'm able to present to you in this picture in the bottom right. On top of that, there was only 2 GPS locations presented in the research, and as you can see here is that actually spans over 92 kilometers that was split up into 21 different sites, and that's just as a bird flies across the area. And so it leaves this very, very large variability in where these potential study sites took place, and makes it pretty much impossible to do any kind of recreation of the study. And then furthermore was just kind of the layout of the scientific names and the introductions of native species and what they were actually studying with the reptiles and the herpetofauna. In the early introduction and in the body, they introduced the species that they were going to be studying, as well as their Latin names, but then referred to them as in their common names throughout the rest of the research article until you got towards the end where they presented all of their data, and then they switched back over to the Latin names. So unless you were an expert in all 11 species of herpetofauna and reptile, and in the 3 species of native plants, you required you to flip back and forth a lot to be able to cross-reference and really put the data together, which was just kind of frustrating from a reader's perspective. So diving a little bit more now into some of the scientific objections I have, or critiques I have for Mosher et al. 2016, was that there was no mention at all of the urbanization around the St. George site, or as we can see now, piggybacking off the previous slide, the coordinates of their control site, only that it was adjacent to the St. George location that they've given. And now looking at this map, it really kind of puts some question marks in my mind as to where that location could have been, and what the potential crossover of species could have been if they were inhabiting both sites. Furthermore, there was no soil test conducted on the site, and as Zavalata 2001 brought up, that Tamarix can significantly alter the soil, and thereby altering the success of native species in the area. And so I believe that that would have been a vital contribution to the work to understand better what the soil composition was of these areas, in addition to the salinity that the Tamarix brings, but also now seeing the level of urbanization around this area, if there was any agricultural runoff or any other contaminants from some of these more industrious areas we see around the St. George location that could have potentially contaminated their sites where they were conducting their studies. And lastly, just the method viability of the research that was conducted. So to the best of my knowledge, as I was reading through the research article, they used 2 primary methods to conduct their research. One was the pitfalls and the various traps that they laid out, and they did a pretty good job of mapping those out in the research article. But then the second was that they used a visual identification where they took teams out and they would scan areas in a grid to try and identify different species. And to the best of my knowledge, what I was reading is that they didn't implement both into a single area, but rather they used one method in one area and another method in another, which to me is kind of that definition of viability. You're using 2 different methods to try and test the same thing, which calls into question to me the viability of the research that they put forward. So the questions I put forward to the class is, do you think that biocontrol is a viable restoration and recovery method? Why or why not? The second is, what does restoration and recovery look like for these areas? Do we simply transplant native plant species into the area and let the herpetofauna come? Do we monitor the soil composition, knowing that the Tamarix can potentially affect the salinity of the soil and the success of native plant species reintroducing naturally? Do we reintroduce native reptiles and herpetofauna to the area, knowing that they have been displaced over a period of time, or can we count on them to just naturally fill those areas as the ecosystem makes itself available? And the third question, kind of in line with the second, is how much should we as ecologists and biogeographers aid in this restoration and in this recovery of this area?